Hi, I'm Eric. I'm a postdoc at UC Irvine in the La Spada lab, and I'm really happy to be part of this Ask Me event to tell you more about my research. So our work is really motivated by this challenge of identifying therapy targets that might be broadly relevant across um, ALS. And the reason this is a challenge is because ALS is only caused by a known inherited mutation in about 10% of cases. Fortunately, for these cases, gene therapy approaches are now being rapidly developed and tested, and some appear pretty promising. However, the remaining 90% of ALS cases are due to an unknown combination of genetic or environmental risk factors, and making it really hard to identify therapy targets in the same way. However, the vast majority of ALS patients do have this shared pathological hallmark, mislocalization of the protein TDP43, suggesting that there is a shared disease mechanism across these broad, different upstream causes of ALS. And so in ALS patients, TDP43, which is normally performing its function in the nucleus, becomes mislocalized to the cytoplasm and eventually forms these pathological aggregates. And what TDP43 does is it performs a number of steps in RNA processing. And so if you remember from Bio 101 days, our genetic material is encoded in DNA, and RNA acts as a message to bring this information to another part of the cell to eventually be turned into protein, which is what carries out most of the cellular functions. However, this process is really much more complicated than that schematic, and TDP43 plays critical roles in various processing steps that occur at the RNA level. In recent years, a number of great labs have done work to understand TDP43 function in RNA processing, and some of the targets that they've identified, like Stathmin-2 and UNC13A, are themselves now being developed as therapy targets for sporadic ALS. My work is investigating another aspect of RNA processing that's known to be regulated by TDP43, but has not yet been studied in the context of ALS. And that's called alternative polyadenylation, which just refers to the fact that at the 3' tail end of an RNA transcript, um, the transcript can be terminated at different sites, which result in either a shorter tail or a longer tail. And this can have really important consequences for how much of this RNA becomes protein, where the RNA is trafficked within the cell. And so this is a critical level of RNA regulation performed by TDP43. And the short version is that we found that hundreds of alternative polyadenylation events are changed um, in the course of ALS, and that this is really a critically important aspect of RNA processing regulated by TDP43. And we're really hoping that some of the important targets we identified will be added to this growing list of targets to develop therapies to potentially treat sporadic ALS. And so with that, I'd like to thank you for your attention, and please feel free to reach out if you have any questions. Thanks.